Yeah. Hello everyone. I, Evaporative, Secretary of TG Thermal Comfort, welcome you all in this workshop on white paper on thermal comfort and overview on Evapcal tool. So before going further, let me read the code of ethics for ISHRAE. So in this ISHRAE meeting, we'll act with care, dignity, and consideration, upholding all values of trust, teamwork, meritocracy, and justice. We shall not exploit the society's forum for any commercial or personal gains and shall avoid all real or perceived conflicts of interest. And that our thoughts, word with action, shall not besmirch this image and standing of ISHRAE. Thank you. So let's start the webinar. So first, I would like to invite Vishal Kapoor, who is the chair of ISHRAE Technical Committee, to give a brief about TG activities. Vishal, sir. You are not audible.
Am I audible now?
Yeah. Nice.
Oh, sorry. So thanks, Driver, and a very good afternoon to all the delegates who logged in for this very important workshop on topics which are very current and which are very important during all courses of days. But in these days of still fighting this pandemic, it is of utmost importance. You've seen on the flyer and you heard Vaibhav talk about this concept of TGs. And some of you who would not be much aware would be wondering what is this whole thing about. So this TG basically means a technical group. And a few years back, ISHRAE decided that we need subject matter experts running every possible part of this heating, ventilation, air conditioning, and refrigeration industry. That means whether they are systems, whether they are products, whether they are basics, whether they're design-based, they're service-based, they're passive systems, all aspects which cover HVAC and R need subject matter experts handling those. So in that pretext, these technical groups got formed. Today, we have 30 plus technical groups under the ISHRAE technical structure. Each group is on one particular subject. For example, today you have two technical groups who come together, evaporative cooling and thermal comfort. Now, these technical groups get into every activity that is needed for that subject. That means, for example, we need to develop a publication. It could be a big handbook, or it could be a short, small white paper or a position paper. Is developed, and then get it peer reviewed by these technical groups. We are in the business of developing standards for products or systems or processes. So, for example, we have a standard of commissioning HVAC systems, which was launched last year. It was developed by the commissioning technical group. Then we also undertake research projects in partnership with some of the premium engineering institutions in India like IIT Roorkee, etc. Again, the subject matter technical group or groups, depending on the research project, get together to handle and run these research projects. Then ISHRAE does a lot of educational programs, short-term, long-term certified professional courses, or the diploma courses, which has multiple subjects in it. So these technical groups handle their part or their portion of these courses to ensure that the courses are industry-specific, easy to implement, and practical. And similarly, all short-term webinars, 1 hour, 2 hour webinars, like what we're doing today, a short-term 2 hour workshop is also run by these technical groups. So in a nutshell, anything and everything to do with that particular subject matter from the technical point of view is handled by these TGs. A TG can have as many members as possible, though there will be 6 voting members, but otherwise corresponding members can go up. So that is the whole way this TGs work, and it's been very successful. And every year we plan to keep on adding 4 or 5 TGs to this entire system, so that we are able to cover literally every spectrum or every aspect of the HVAC in our industry. We look forward to today's session, which is a culmination of 2 TGs coming together and working hard. You'll hear Dr. Mathur after me talk a little bit more about that. Welcome all to either join the TGs if you want to devote time, or benefit from the various activities that ISHRAE is doing. Log on to our website, ishrae.in. You will see a huge amount of resources over there. You can get into a knowledge bank. You can get into an online shop where you have a phenomenal number of books all technical in nature, available for you to buy, download. It's the best place to go if you want to learn anything in this HVAC in our industry. Whether you are a beginner or whether you're a professional or whether you've been 50 years in this business, learning is constant. And that's what the TGs and that's what ISHRAE is trying to do. Thank you very much, Vaibhav, and look forward to a very good workshop.
Thank you, Mr. Vishal, for a brief introduction about all TG activities. Now I would like to invite Professor Mathur for welcoming address and a brief about thermal comfort TG.
Thank you, Vaibhav. Can you see my slides?
Yeah.
Okay, thank you. So once again, a very warm welcome to all of you who are attending this workshop, which is a combination of efforts from two TGs, as Vishal Kapoor has recently said. So before I move little into what exactly this contains, this TG group, which I am representing as a chair, is Thermal Comfort TG. And the very reason of this group existing is that thermal comfort actually is the very cause of existence of this industry altogether. If we were not demanding thermal comfort, probably this industry would have not been existing in the shape it is today. So you can really imagine the importance of this topic, thermal comfort. If we shift our expectation of thermal comfort, maybe the way systems are designed, sized, and operated, they will change altogether. And that is why it is important that we see, we understand, and we really practice thermal comfort in a very professional manner, utilizing the latest knowledge that is there existing. So, as I said, I have the privilege of chairing this committee, technical group. We have Dr. Shivraj Dhaka, who has done PhD in this very area. He is the vice chair. We have a very energetic secretary, Vaibhav Khare. He has done masters very close to this area, and he pushes all of us hard, and he sets targets for all our thermal comfort group actually. And we have 4 subcommittees which are very active. One is the standards subcommittee, in which we are feeding into various standards. For example, the ISHRAE IEQ standard. That is one of the most successful standards ISHRAE has used, or the commissioning standard. So this TG feeds, give inputs to the development of these standards wherever we feel that it is appropriate. That is one. The second group is research. Wherever we feel that there is a requirement of doing a fundamental research or applied research or a data collection or any other thing, it is this subcommittee of our thermal comfort technical group which takes charge and comes in picture. For example, nowadays, a topic that is under consideration is by what extent productivity gets affected if I'm not providing appropriate thermal comfort to occupants, whether by overcooling or undercooling, whether by not controlling the humidification, whether by making and allowing the interior conditions to be very dry. All these things, these are very important, and this research committee is formulating a research project these days on that. Program committee is very active, and I would give full marks to our energetic chair and co-chair of this subcommittee, Mani and Yusuf. So they are doing very well for organizing various events, and the publication committee, in which we have a faculty member from IIT Bhilai, Dr. Uday Raj. He is leading the effort, and he is also pushing all of us to bring out useful publications to the committee. So all in all, these 4 subcommittees are very active, and you can think of joining whichever subcommittee you want and contribute in a meaningful way, or at least utilize the work produced by them. So what has been done so far by this group? A white paper, which you will be hearing more about in a few minutes from now. We have developed the chapter for thermal comfort, and we plan to add it in ISHRAE fundamentals and other relevant books now onwards, and that is done jointly by collaborative efforts by 4 or 5 members of this TG. We were jointly developing a tool with evaporative cooling TG, and EvapCal is the outcome. So this tool has been a collaborative effort of TG F101 and TG B103. You will be hearing more about this from the chair of that TG, Mr. Nishant Gupta. Actually, EvapCal was the brainchild of Mr. Nishant, and he is the most appropriate person for this. I would say this TG has also been doing few other things. For example, doing webinars. We had in COVID work time, we had conducted a webinar about what can be done now in this era for mitigating the effect of COVID. And then we have been doing collaborative work and panel discussions and all of the things. So I will come to the end of my brief introduction about this TG. If you want to know more, please write to Evaporative. His mail ID is written on the slide, or you can send an email to ISHRAE officials and they can forward it to us. Please join this TG because this TG is very active and it finds linkage to various other TGs as well. For example, there is a task that we are also doing, radiant cooling, you all have heard of, evaporative cooling, you know. All of these may have a different bandwidth of temperature, humidity, tolerance in terms of thermal comfort. So you may get good opportunity to work very actively in this TG. I will stop here and I would, you can say, allow or introduce Sandeep, Kachhawa, and Priyam is not there as a speaker because we just wanted one speaker to be there. So Sandeep and Priyam, these two, they were the primary authors of this white paper that this TG produced. Priyam is one of the committee members of ISHRAE 55 2020 version also. So there was no better person than Priyam because she was well versed with what is happening latest in ISHRAE 55, which is the thermal comfort standard used most widely in the world. And Sandeep has a long experience of developing white papers and similar documents, whether you can say his experience with AEEE or TERI. So the combination of Priyam and Sandeep was apt for developing this white paper. Of course, other members helped very positively and contributed significantly to the white paper, but let's hear it from Sandeep today about this white paper. And after that, let's hear from Nishant about the EvapCal tool. Thank you very much. Over to you, Vaibhav.
Thank you, sir. So now I'd like to invite Sandeep to enlighten us on the white paper on thermal comfort. So very brief about Sandeep. So he has more than 10 years of experience in consultancy and policy advocacy. And he contributed to various cooling focused studies and part of the very known project that ICAP India Action Cooling Plan. And he is a certified CMVP and helped improve the energy performance of many large commercial and mixed use buildings in India. And he's a mechanical engineer and has done his MTech in energy engineering from MIT Jaipur. So over to you, Sandeep.
Thank you, Vaibhav. I hope I'm audible.
Yeah.
Thanks, Vaibhav. Thank you, Jyotirmay sir. Thank you, Mr. Vishal Kapoor. Hello, everyone. Good afternoon. My name is Sandeep Kachhawa, and today I'm representing the ISHRAE Thermal Comfort Technical Group. Let me share my screen to start my presentation on the white paper that the group has prepared. Vaibhav, can you confirm if my this presentation is visible?
Yeah, it's visible.
Okay, great. So before I begin, first let me thank the entire team of the ISHRAE Thermal Comfort Technical Group who have co-authored this white paper. Professor Jyotirmay Mathur, Ms. Maya Varta, Mr. Nishant Gupta, Dr. Priyam Tiwari, who contributed significantly in drafting this white paper, Dr. Shivraj Dhaka, Dr. Udayraj, and Mr. Vaibhav Rai Khare, who is also moderating this session today. Yeah. To begin, let's look at the objectives first. So this white paper provides an overview of 4 aspects. First, about thermal comfort basics, where we try to understand what is thermal comfort and what are the different thermal comfort assessment approaches. The second objective is to give a brief about various strategies to improve thermal comfort in the most environment-friendly manner possible, how we should design, build, and operate buildings and cooling systems. Third, we looked at the evolution of international thermal comfort codes and standards and how thermal comfort is addressed in our national standards. And finally, we did a review of thermal comfort research in India with a focus on adaptive thermal comfort. Here we reviewed research papers and looked at the research focus areas and mapped what all national and international institutes are active in this domain in India. And on the basis of this overall study, we have identified research gaps on thermal comfort in India. This white paper can help facilitate ISHRAE and, for that matter, even other institutions to strategize the activities in the thermal comfort domain. So let's start with thermal comfort basics. So the most often cited definition of thermal comfort is that it is that condition of mind which expresses satisfaction with the thermal environment and is assessed by subjective evaluation. Now the key word here is that it is assessed by subjective evaluation. And in the next slide, we will see how this subjectivity has impacted the thermal comfort assessment approaches. Now let's look at the factors that govern thermal comfort. These can be broadly classified into two categories. First is personal factors, which are sometimes also called physiological parameters. These are essentially the characteristics of the building occupants. These are occupant clothing level and metabolic rate. Clothing level is measured in Clo and expresses the thermal insulation provided by garments and clothes. And metabolic rate is the rate of transformation of chemical energy into heat and mechanical work by the metabolic activities of an individual. And this is measured in terms of energy produced per unit skin area. The second category is environmental factors, which are also called physical parameters. These are the conditions of the thermal environment around the occupant. These include indoor air temperature, which is the average dry bulb temperature of the air surrounding the occupant. Vertical air temperature difference, which is the air temperature difference between the head and ankle level of the occupant. Mean radiant temperature, which takes care of the radiative heat transfers from different surfaces around the occupant. Radiant temperature asymmetry, this is the difference between the radiant temperature on opposite sides of the occupant. Floor surface temperature, relative humidity, airspeed, all of these are the remaining environmental factors that govern thermal comfort. And apart from all these parameters, the kind of food and drink the occupant had, their acclimatization, body shape, body mass index, age and gender, and even the state of health affect thermal comfort and heat dissipation from the body. Next, we come to thermal comfort assessment approaches. So the traditional approach has been that of heat balance. These are based on climate chamber studies where the environmental conditions can be very accurately controlled and comprehensive measurements can easily be conducted. The problem with this approach is that it does not reflect everyday life. So here the comfort is determined by heat exchange between the person and the environment, wherein the person is treated as a passive recipient of thermal stimuli. So in short, this approach relies strictly on lab-based comfort standards and ignores important cultural and social differences in the need or desire for air conditioning. And to address some of these concerns, an adaptive approach was developed. Now, this is based on field investigations in normal settings of daily life, in contrast to the climate chamber studies in the heat balance approach. So here also the challenge is that the measurements are intrusive and sometimes difficult to carry out in the real world. But the important thing is that it recognizes that thermal comfort is beyond heat exchange between the person and the environment, and it also incorporates physiological, behavioral, and psychological responses of the person and the control opportunities offered by the design and construction of the building and the cooling systems. This quotation that I have taken from a paper by Humphreys and Nicole summarizes the adaptive approach to thermal comfort. If a change occurs that produces discomfort, people tend to act to restore their comfort. And today, adaptive thermal comfort research around the globe has revealed that a wider range of acceptable temperatures is possible, and that it depends on the climate, the building construction type, and behavioral controls as well. Now let's look at the strategies to improve this adaptive thermal comfort while also minimizing the adverse environmental impacts associated with cooling. So the three interdependent strategies are climate responsive building design, climate responsive cooling system design, and building occupants adaptation. Now let's look at them one by one. So when we talk about climate responsive building design, the role of the building architect becomes the most important. And most of the things that we will discuss in this slide actually lie in the scope of the building architect. So many design guidelines and codes such as the National Building Code, other building bioclimatic charts, analytical tools are actually available for identifying appropriate design strategies for a climate. Here the top priority should be to reduce the heat ingress into the building and carefully choosing building orientation, designing shading systems as simple as an overhang or a chhajja, and provision of buffer spaces to reduce or minimize solar exposure. These should be the first design feature that should be considered. Then while designing the building envelope or choosing the building materials, thermal mass, or cavity walls, reflective surface finish for wall and roof, or green roof, insulation layers in walls or roofs, all these things should be considered. So the key message here is to shade and insulate, which applies to all kinds of buildings in a tropical kind of climate. Next, some passive cooling strategies could also be integrated into the building design. Natural ventilation through stack effect or wind-induced pressure differences, or wind towers can be considered. Courtyards is another building design feature that could be integrated. And as I said, many design guidelines are actually available to choose these design strategies from. But the important thing is that they should be carefully assessed for the prevailing climatic conditions. Now let's look at climate responsive cooling system design. So if you have done what we discussed in the previous slide, that is controlled the solar heat gains, provided good thermal inertia, integrated passive design features, then the building already requires much less intervention from active cooling systems. So here the first thing to note is that active air conditioning cannot be considered as the only means to provide adequate thermal comfort for all. So we have to look at alternate and not-in-kind cooling technologies, some of which are suggested by the National Building Code and even the India Cooling Action Plan. Pre-cooling of ventilation air through heat recovery wheels, evaporative cooling, desiccant dehumidification, geothermal cooling, earth air tunnel, radiant cooling are some of the options. Additionally, alternate cooling technologies such as thermal energy storage, personalized cooling, tri-generation, district cooling, solar vapor absorption, all these can also be considered. Now to simulate and analyze some of these systems, particularly the different evaporative cooling systems, the designers can use analytical simulation tools such as EvapCal, about which we will hear more in the next session. So once we have taken care of climate responsive building design and climate responsive cooling system design, we have prepared the groundwork for better adaptation and more favorable occupant behavior. Things such as such as behavioral or technological changes, which include adjusting the window openings, switching on air circulation fans, adjusting thermostat set points, changing the activity, among many other such measures can be taken. And second adaptation is psychological adaptation, which includes changing expectations and preferences. And this is also this also plays a major role. And finally, acclimatization, which mainly takes place in the first week of exposure to heat, is also equally important. And this has come out of many field studies that Indians have wider comfort bandwidths compared to people residing in cold countries. So the key message here is that building occupants adaptation, especially behavioral and technological changes, is an important strategy to improve thermal comfort while minimizing the environmental impacts of cooling. Now we look at national and international thermal comfort codes and standards. So many codes and standards are available which prescribe thermally acceptable environmental conditions. ISO 7730 prescribes indoor thermal comfort using PMV PPD method. ISO 17772 defines indoor environmental quality holistically, including thermal comfort, air quality, and visual and acoustic comfort. The ISHRAE standard 55, which is the most popular thermal comfort standard, offers different comfort zone methods, including an air speed method and adaptive thermal comfort method as well. The European standard is EN 15251, which is now superseded by EN 16798. The EN standards, like ISO, also prescribe indoor environmental quality parameters holistically. Unlike ISHRAE standard 55, the EN standards also have a separate adaptive thermal comfort method. In India, we have the National Building Code, which has three different thermal indices for our climate: standard effective temperature, tropical summer index, and adaptive thermal comfort, which are applicable for different types of buildings. Then ISHRAE also has its own indoor environmental quality standard 10001. And like the ISO and EU standards, it also prescribes indoor environmental quality parameters holistically. This particular slide shows how the thermal comfort zone in ISHRAE standard 55 has evolved or expanded over the years. So the shape of the comfort zone on the standard psychometric chart was like this in 1981, what you see on the top left of your screen. Then in 1992, the comfort zone expanded slightly to become like what you see on the top center of your screen. And it further expanded to become like this in 2004, what you see on the top right of your screen. So this was the first time when adaptive approach was introduced in ISHRAE standard 55. And for the subsequent editions, 2010, 13, and 17, it remained like what you see on the bottom left of your screen. And finally, this is how it looks in the most recent 2020 edition, which you see on the bottom right of your screen. So what these revisions also reflect is that the evolution of thermal comfort research and the acceptability of adaptive thermal comfort principles among the wider community. Next, we looked at all thermal comfort related research work in India, which was published in peer-reviewed journals or conference proceedings since the publication of the Tropical Summer Index in 1986. In all, we reviewed 64 research papers and compiled the research focus areas and did a mapping of what all national and international institutes are active in this domain. Most number of research were conducted on survey of building occupants' thermal comfort perception. I will not go into the details of each and every research focus area and will encourage those interested to actually refer to the white paper. In all, 23 national and 9 international institutes have been active in India over the past 35 years. We also observed that there is limited research on the validation of actual energy savings through adoption of adaptive thermal comfort standards. And actually, there is no research study on in situ monitoring of energy performance impact of adaptive thermal comfort based AC operation. Now we come to some suggested adaptations and changes in the air conditioning system operation that is worth noting in the Indian context. First, it is clear from the adaptive thermal comfort research that there is no such thing as a fixed optimum comfort temperature. Hence, instead of a fixed set points, the concept of an adaptive set point for operating air conditioning systems at a variable thermostat setting should be explored. Second, designing an occupant-centric building with greater emphasis on providing the occupant with controls such as operable windows, doors, fans can escalate the thermal comfort while reducing the building energy consumption. So here, in addition to controls offering improved visibility to building occupants on environmental conditions, both indoor and outdoor, and energy will further help the cause. Third, changing the clothing is the most obvious and commonsensical behavioral adaptation in accordance with the changing outdoor temperatures. And this is already practiced in many naturally ventilated buildings. But why can't this be the norm for all types of buildings? So generating awareness on clothing adjustments is extremely important. And just a case in an example, in Japan, there's a program called Cool Biz. It is about liberal summer code for clothing, along with changing the air conditioner temperature set 1 to 24 degrees C in office building. And it has achieved substantial energy savings. So there are learnings for us as well from that experience. And finally, there should be greater emphasis on elevated air velocity to restore thermal comfort, especially in naturally ventilated and mixed mode buildings. And for reference, ISHRAE IEQ's air velocity offset chart for Indian subjects can always be looked at. So based upon the review of national thermal comfort research and its applications in India, the following gaps and challenges have been identified with respect to larger adoption of adaptive thermal comfort based building design and operation in India. First, more India-specific research on quantifying the impact of adaptive thermal comfort on energy savings, occupant health, and well-being can be conducted for different building types, operation modes, and climatic zones. Second research gap is around the interplay of building design with adaptive thermal comfort-based cooling system design and operation. Next, more research on behavior change communication for promoting greater adoption of adaptive thermal comfort-based cooling system operation is required. There's a need for research to understand the AC users' motivations, attitudes, and behavioral tendencies in the Indian context. Field studies on adaptive thermal comfort impact in buildings with passive or low energy cooling systems are needed. In this regard, research on quantifying best comfort strategies for the design and operation of mixed mode buildings will also be beneficial. There should be more focus on developing pre-designed tools based on the thermal acceptability limits drawn from India-specific studies. And ISHRAE's EvapCal tool is an excellent example. EvapCal is based on a building bioclimatic design chart for evaporative cooling based on field investigations carried out in India. Next, there are many complexities in the adaptive model calculations that need to be simplified. These include deviation of actual adaptive coefficients from the established models. And further, there is ambiguity in calculation of outdoor reference temperature as well, which is the most important input variable in the adaptive model. And finally, standard effective temperature SET-based approach, which includes all thermal comfort parameters, air temperature, mean radiant temperature, air humidity, air velocity, clothing and activity level, should be explored over the operative temperature, as it may be more comprehensive and suitable to evaluate comfort. Now, this is my last slide, and it's a call for action for the ISHRAE community based upon this white paper. First is to support research proposals. So in order to address the challenges with respect to the adoption of adaptive thermal comfort standards, the ISHRAE research community can prepare research proposals for selecting and supporting the identified research gaps. With so many research institutes active in this domain in India, the research proposals will likely invoke a lot of interest among the target stakeholders. Second, the ISHRAE can initiate large-scale awareness programs and campaigns to change public's perception about adaptive thermal comfort principles. The ISHRAE regional chapters and sub-chapters can organize seminars or workshops on various topics related to thermal comfort. The upcoming ICREX or Urjavaran and other ISHRAE flagship events can also have a focused discussion on the thermal comfort theme. And finally, focused implementation of the 1 degree challenge. So let me provide some background to this. So the Bureau of Energy Efficiency has taken many steps to spread the message of energy savings through raising the AC set point temperature. It has mandated the default temperature setting of all ACs in the star labeling program at 24 degrees C. B has also issued voluntary guidelines to all commercial building consumers to maintain the temperature set point between 24 to 25 degrees C. And we even launched awareness campaigns on various social media platforms on energy and cost savings through raising the AC set point temperature. And taking forward these BE guidelines and awareness campaigns, ISHRAE had launched this 1 degree challenge, which encourages AC users to operate their air conditioners at 1 degree higher than 24 degrees C, or the current standard operating temperature, which may even be 23 or 25 or whatever. So this challenge was supported by all the members of the Board of Governors of ISHRAE from more than 43 cities in 2019. But now there's a need for focused implementation of ISHRAE's 1 degree challenge, as it can reap huge energy saving benefits due to the large base of air conditioning systems in India. And with these 3 key messages for the ISHRAE community, I end my presentation. I'll be happy to answer any questions. Thank you, everyone. Over to you, Baba. Thank you.
Thank you, Sandeep. It was a great presentation. So we'll take all the question at the end of this webinar, or if you have any question, you can write it in the chat box. We'll try to resolve during the webinar or at the end of webinar. Sandeep, if you can stop
here.
Yeah, thank you. So now I'd like to invite Nishant for the next session, that is overview and Evapcal tool. So Nishant is Managing Director of Degree Day Private Limited. He is currently serving as a role of Vice President Technical in ISHRAE headquarters. Also, he is the President of ISHRAE Western India chapter of Ahmedabad, and he is currently chairing ISHRAE TG 101, that is evaporative cooling and standard for evaporative cooling system. He is a mechanical engineer and has done his MBA in marketing management from IMS Indore. Over to you, Nishant. Thank you.
Thank you, Weber. A slight typo correction, which I would like to make in my introduction. I'm the immediate past president. It's my error. Just wanted to clear it. Currently, Dr. Yash Shukla is the president. Anyhow, coming back to the subject, I'm glad to be here with all of you. And since we have understood the basic fundamentals on thermal comfort, invariably, we had been blindly following central air conditioning, or I would say air conditioning, as part and parcel of the business that we do day in, day out. Probably because we might have forgotten the basic fundamentals, which our elders used to take it forward, or we don't have the right tool to analyze and commit to a client who's looking forward to a great solution of energy efficiency, as well as getting something which gives the person thermal comfort. So with this note, I would start the introduction of a very innovative tool which was launched by the society last year, joint efforts by both the technical group, as Dr. Mathur mentioned. It was named as Evapcal because it helps you to understand the challenges that evaporative cooling gives to you and the solutions that it can provide. The basic objective was to uplift the evaporative air cooling industry, and if not in India, nowhere else probably. We are blessed with a weather condition which largely can support evaporative cooling for most parts of the year, and we'll see how. The common questions that you as a designer or as a user might have while thinking of any type of evaporative cooling, may it be a single or two-stage or hybrid, one that is evaporative cooling a right solution wherever you are? It might not be true, and it might be true. What are the temperatures that you can actually expect in the space? Like when we do air conditioning, we define my indoor conditions, and we ensure using the air conditioning systems that we achieve it across the year. If we have to go with air cooling, how many days I would be uncomfortable, or vice versa? When we talk of comfort, which is the comfort level that we are referring to? The thermal comfort of ISHRAE 55, or the user-defined thermal comfort level, or the Indian adaptive thermal comfort level? So what kind of system is good? How should I size it? What is the saving potentials? What should be the water consumption? How many hours I would be running air conditioning, and how many hours I have to use air cooling if I have to get a perfect condition? So is there an informed way that I can take this decision, or a scientific way to do that? These are the questions that this tool tries to address to a very large extent. It is meant to be used by all the HVAC and MEP designers and practitioners. It could be contractors or even manufacturers of this kind of systems, or end users who would like to evaluate this as an alternate to a conventional system. So the EvapCal works by taking basic inputs which are being provided by a HVAC person in terms of feeding in the heat load details of that space, which can be done by any simple tool which you're using or advanced tool. And you can give the basic selection of the parameters of various manufacturers from which you are considering the product in terms of saturated efficiencies that their products would be working on. And then you can get out the results that what is the end outcome. So the basic features which I would like to highlight is that it is preloaded with all the Indian cities hourly weather data. So it gives you the ambient design selection, and that answers you that is my place right to go for air cooling systems. It also, based on the input that you would provide of the heat load of the space, would give you the exact capacity which is recommended to achieve the designed thermal comfort. You can very well set what is the thermal comfort that you would like to choose from. Shows a comparison that if you are following a ISHRAE 55 thermal comfort model, or you are using a user-defined thermal comfort conditions, then what are the hours that you would eventually be able to achieve the comfort. It also gives a flexibility to select the operating hours. Now, anybody and everybody might not use the equipment across the year. There could be a case like in a residence, somebody says that I come back from my office at 7 p.m. and I want to use air cooling only in the evening hours or night hours, how much thermal comfort I can achieve, or how many days in a year I would be able to achieve the thermal comfort. There could be a school application where they're running it from morning 8 a.m. to 2 p.m. and they would like to analyze this as an option. Or there could be a restaurant which is running from 4 p.m. till midnight and would like to explore this alternate over the conventional air conditioning system. So this tool would help you give an hourly analysis, show the outcome on psychometric chart, give you 2D and 3D heat maps, gives you a calculated peak power consumptions and the water consumption data, and generates a customized report that can be submitted by you if you are as a contractor would want to give it to your client. And the outcome can also be exported in the Excel sheet so that you can do further iteration and correction, whatever you'd like to. And mind you, this all comes free if you are a member of ISHRAE. If you are not, please log on and join ISHRAE. If you are, please download this tool, which is freely available with a design guide, the basic tool, or the basic disclaimer, which is required, how to run and operate it, and you'll be able to do that. So what I'll do from here is that I'll stop sharing my presentation screen and I'll open up a screen showing the tool. So, okay, so this is the tool which I have installed. It gets installed on Windows and I would run click. So once I have run this software, okay, now I believe my screen is much more visible. Let me hide my screen. Okay, perfect. Now you'd see this is the home page of the tool, and you can select the city from a predefined list which is available over here. These are the cities which encompasses most of the towns in India. And if you have an EPW weather file, you can also browse it, download it from the web, and plug it in the software and start using it. So from here, you select the city, or you can also open a saved project. So due to paucity of time, I'll try to open one project which I had tried to run across a simulation, and let me see if I can find it quickly. Okay, so there you are, projects. Okay, so I've selected a pre-worked on project, and so now you can see that the city has been selected. I can do the revision number. If I'm doing one calculation, I want to revise it. I can write the client's name over here, and I can write the designer's name over here, whatever I would like to. And mind you, these all helps when you have to come out with your report, which you want to submit to your client. Now, I've typically used a small area of say 1200 square feet, considering a 10-foot height. Now you'll see that automatically based on the city, the ambient design conditions have been put in. You can select the maximum indoor conditions. Say, for example, this for industry, and people say that, okay, I don't want to exceed 30 degree, or let me put it as 28 degree. See, that is my upper limit. And I don't want the humidity to go beyond 80%, or let me put it as 75%. I have to punch in heat load data, which is BTU per hour, from any third-party software. We are working on the next version where we might like to include this part as well. But as of now, we wanted to be flexible. So you need to mention the sensible heat load of that space and the total heat load which is required. And select that whether you want to do a direct or indirect or a two-stage. So for now, let me consider a two-stage evaporative cooling. And I've put in the saturated efficiency of my direct evaporative cooler, which is a data which any manufacturer of the air cooler, whichever you're considering, or basic fundamentals, you would know that, okay, I'm using a cellulose pad. It will give me 85% direct saturated efficiency, and an indirect one might give me say 55%. And if this is the outlet condition, then there'll be some losses in the temperature rise because of the ductwork. If I would like, I can add this 0.5 degree, or I can make it 0, and I'll calculate. Now, once I press calculate, you will see that earlier it was done for a single stage cooling, which was calling for about 8800 CFM. Now it is converted into 5780 CFM. So you know that how much energy saving I can actually achieve in my total airflow systems if I'm changing from single stage to stage. Similarly, it will also indicate that what is my supplier condition based on the saturated efficiency of the product, and what is my supplier humidity, how many air changes it is actually delivering, and what is the peak water requirement, considering without any bleed off. This is just the pure evaporation based on the psychometric analysis. And once I've done that, I can also see various kind of graphical inputs like ambient DBT. Now, this is for typically indoor. What is the ambient temperature which is there? If I want to see this in a 3D heat map, I can see that as well. Similarly, I can see for the relative humidity also. Now, these are all data which is related to the ambient condition. And I also want to see that what would be my indoor conditions for across the year. So if I'll see, it will give me the room air conditions based on the heat load that I've provided and the saturated efficiency. This gives you a wide range of awareness of what kind of temperatures you can expect. If you want to be very specific, again, this can also be seen on an indoor 3D heat map. So similar data can be run, and it will show you what is the room indoor air temperature conditions. Now, these are the indicative ones. If you want to deep dive into it, you can always download the Excel and also do further analysis. Now I'm going to the next part of it, and it shows the process on the psychometric chart. Now here you see that we've considered the user-defined comfort zone. If I want, I can use that ISHRAE 55 model, and it will show me that under ISHRAE 55 model, this is the time, 31% of the time I'm feeling comfortable. If I consider Indian composite bioclimatic comfort zone, then this will indicate me that this is the climatic zone which is being considered as acceptable. This is how the process is happening. First indirect, then direct, then taking up the heat of the space. And these are the various points where the outcome could be there. And now you see that out of 8760 hours, because of direct evaporative cooling, 5863 is happening. Because of indirect 5000 hours, it's getting the results. And for two stage 6000, so about 69% you're able to achieve the desired condition, and gives you a summary over here. You can also change the room air velocity of the outlet. If you change the grill velocity, I mean the outlet air velocity, then you will also see the impact of changing the air velocity on the thermal comfort. Now you'll see that this bioclimatic comfort zone has been slightly expanded, and now the comfort hours have tremendously increased to 90. So you can do all those permutation combinations. Here you can also run a customized report about annual or summers. If I just want to see that I want to do a summer conditioning from 1 hour to 24 hours, or I can set my operating hours that for what hours I want to do. So say I've considered summers, I would see that now only 1416 hours have been considered, of which 85% times I'm able to achieve that thermal comfort. I can also punch in the data of the power consumption. Once you know that what is the CFM which is required based on the static pressure, you'd easily be able to identify the power consumptions of the motor. You can punch in that data or from the manufacturer's catalog. And you can also mention that if you're comparing it with, say, a VRF system, you'd like to consider 0.9 kilowatt per ton kind of situation, or you're considering with a DX system, you might like to punch in, say, for example, 1.1 kilowatt per ton. And that is how it will capture that in the final report. Now, once you go on next, it gives you a summary that 1200 square feet, 10 feet of height. This was your total sensible heat load and the total heat load. Your required capacity is 5780 CFM, 29 air changes. It will be good out of 1416 hours for 1209 hours, 85% of the time, and 15% of the time, it will be outside the comfort range that you've selected for. Your water consumption without the bleed off based on the psychometric analysis. This is the data based on your manufacturer's catalog that you've punched in 1 kilowatt of energy. And if had been an air conditioning, then based on the total heat load that you've punched in, it requires a 8 TR system. And because it was 1.1 kilowatt, it generates 8.8 kilowatt of power consumption. So you might expect about 89% of the power saving. Now you can save this project, you can export data as an Excel file, or you can generate a report. So I'm generating a report, taking a 3D map into the consideration. Once this report is being generated, this is getting saved automatically on a folder on your C drive as a PDF report mentioning the client name. Now I'll go and try to open and locate this. So you'll see a PDF report. Now this is the report which has been generated by this tool. And you can see now this is a 6-page report, which is mentioning that this is a design report on thermal comfort level using evaporative cooling strategies for your client ABC and by your company. And this is the basis of design. This was a project, the city, your project number, date, what time it was actually, the report was run, what is the ambient conditions of the city that you have taken up, what is the maximum allowable indoor conditions that your client has asked you to, and what is the operating period. Like since we've considered only the summer, it's mentioning 1st February to 31st, the particular months that you've selected, and the operating hours, and this 2-stage evaporative cooling. So Indian Composite Bioclimatic Indoor Chart is the comfort standard that we are referring to. This is the air velocity. And this gives you again the summary of that result with the recommendation that based on the above calculation, about 85% of the time you would be able to achieve your thermal comfort. And if you want to achieve 100% times, then you might like to have an alternate strategies which is required. Gives you a result in a pie chart and gives you your room.
Nishant, sorry, I'm interrupting. Your screen, you're still on the tool. If you're sharing something, we can't see that.
I'm so sorry. I am so sorry. Just hold on. Okay. So is this visible now?
Now it's visible. Thank you.
Okay, I'm so sorry. So this is the 6-page report that actually I was referring to, and it shows you the design basis report. On the first page, it shows the details of the project, and this is the basis on which you've designed it. This is the calculation summary report and the recommendation, and it shows the expected room conditions, also shows the process on psychometric, and gives a disclaimer. Now, this disclaimer is very important. I'd like to read out. Mind you, as I informed you that we've taken the heat load from another tool, we have used it only at a peak load condition. That means it is not actually considering the entire hourly variance in the heat load, but only at the peak is what has been considered right now, but gives you a fair idea on in terms because it's taking the peak part of the load. In case of indirect evaporative cooling, the heat exchange between the secondary air and the primary air is assumed to be equal to the heat exchange between the water and the secondary air. The outdoor design conditions between the range, the daily range of 0.412%, you can always choose from it. And based on this, the users could actually take the decision. Now, this is how this report comes up. And if you want to see, okay, if you want to see the Excel tool also, I'll just try to save that as well. Okay, so I'll export the data as an Excel file. Now, again, it shows that it has been saved in Excel report. So I'll just stop share it and try to open up from my system. Give me a minute. Yeah, there you go. So here you see the outcome which is there on that file, which was again in an Excel sheet. So the basic data, whatever was there, the results that are there. And if you want to see the annual data of the ambient, the supply air, and the indoor air, it's available for entire 8760 hours and whatever customized operational hours that you have wanting to. So that's how the month, hours, and so on and so forth. So this is basically the power of this tool. It gives you a basic fundamental knowledge on how the strategies can be deployed. You can see the impact on the thermal comfort if you go for a single stage or only indirect or a combination of that. And you can maybe take an informed decision so that the end result is achieved. With this, I would like to end the presentation, and I have 4 minutes left now for any question answers, and we can take it forward as per you, Weber. Weber, over to you.
Yeah, thanks, Nishant. So there were a few questions which the panelists have already answered. So there is one open question. So there is some issue with opening the EvapCal software. So I have asked a concerned person to contact. So if you can explain the error. The person is saying that it is showing that your ISHRAE membership number has exceeded the limit of 3 devices on which this software can run. And
That's
he
right.
is saying, yeah, and he is saying that he have installed the software only on 1 device. So,
Well, normally it doesn't happen so because it is very detailed, verified system. But still, on a particular case, if there is an issue, I would request you to please write to me on nishant@degraded.in, or you can email to ISHRAE. The concerned person would reach back to me, and we'll arrange to sort this out.
Nishant, there is a question: can student members also download the software?
They can very well download. I'm not sure if their membership ID has been made valid. Maybe this is a question which I can note and I'll come back on it. Or if we have somebody from the headquarters staff, maybe if we can get the answer to it.
I can check that. So just give me a second.
Yeah, sure.
There are a few interesting questions in the chat box, although I have answered to the persons who posted the questions, but let's take them up and discuss. If time permits, Weber, do we have time?
yeah, we have around 5 minutes.
At least 3-4 questions which are interesting. First of all, on thermal comfort, there is one question. Is type of building, ventilation rate, and heat gain of building not part of thermal comfort basics, as discussed in earlier slide? I think the reference is to the slide on which basic parameters and other parameters like temperature, humidity, air velocity, MRT, clothing, these were shown. So I think the slide was referring to the parameters, and ventilation rate and heat gain. These are influencers on these parameters. For example, if you have more heat gain, the temperature would get affected. If you have more ventilation rate, and if it is a naturally ventilated building, the air velocity inside the building, that will get affected. So these are influencers, I would put it as, and the parameters still remain what Sandeep had shown in the presentation. Sandeep, do you have anything to add to that?
Sir, you have covered that pretty well.
Okay. And then we have somebody saying how the standard effective temperature is different than operative temperature. So the standard operative temperature is basically a combination of temperature and MRT, air temperature and MRT. And in a very simplified way, if you have to calculate operative temperature, you average them out. Whereas the standard effective temperature takes into account the correction factor or the modification due to relative humidity also, due to clothing also, and due to metabolic rate of heat generation also. So these 3 factors are not included in the operative temperature calculation, whereas they are included in the standard effective temperature. That is why now even ISHRAE 55 2000 2020 version, that has also started recommending SCP and not operative temperature.
There is one more question for Nishant. So the person is saying this, it's tremendous effort from team in developing tool. However, I was wondering if the result have been validated with some practical research work, or are there any plans for validation in future?
So we have actually, before releasing this tool, it was under testing for almost 4 months. There are close to 24 revisions which were made last year, from 2020 December till we launched it somewhere in June 2021. And the data was, and the tool was given not only to the consultants, it was also issued to the manufacturers, and all the big manufacturers that you would know probably had gone through it. And many have started even recommending it. So yes, the validation was done at various levels.
Okay, thank you. There is one more. That is, EvapCal tools is similar to the eQuest.
Dr. Mathur, you might like to answer.
In a way, in functioning, I would say in GUI, I will be very specific. In terms of GUI, yes. Like in eQuest, you have, every field has a drop-down menu and you have to select the appropriate one. So yes, in most of the fields, we have worked out that user ease has been considered. So you will find it rather, I would say, more user-friendly as compared to eQuest.
I believe in
Right.
terms of the outcome in the reporting, I do not anticipate that it remains same.
Yeah. Not the outcome, but the UI is.
Okay, thank you. There is one more. That can you show time zone for 7 a.m. to 7 p.m. instead of total 8,760 hours for comfortable hours percentage and discomfort hour percentage?
Yes, so I have already showed that you can select customized date and time for which you want to run it, and it can show you the results only pertaining to those hours.
Okay, thank you. There is one more question. Can researcher pitch for funding support under the TC technical group? Can the tool be accessed for academic use by students?
This is a free tool for all the ISHRAE members, and they can use it for the purpose that they intend to. I don't see any harm in it.
Okay. And, which is more accurate parameter, grill face velocity or terminal velocity? This is
A thermal comfort person would always, we are all designing the systems for human thermal comfort. So it's the ultimate terminal velocity where the person is standing or sitting, which makes the difference. Grill velocity is only assisting to achieve that.
In fact, we often talk about the mistake that many people do. Why are we cooling space, whereas the target is to cool people? So why don't we focus on cooling people rather than cooling the entire space? That's always the question of design.
Okay, so I guess that's it from the question side.
And
So
for
there is
the
one.
for the EvapCal software, as of now, it is only for the members, not for the student members.
Okay.
Yeah.
So any student member who would like to do it, I'm sure their student coordinator would have a regular membership ID, and you can connect to your student coordinator and he can very well install it in your library, and you can do that analysis.
Above, there is one Kumar Nadunri. I think there is a question for me.
Yeah, Salon, if you can unmute Kumar Nadunvi.
Okay, sir. That's Mr. Arun Kumar, right?
Kumar Nadunuri.
Just see the chat box. But in the meantime, I think there is a question which can take. Are there open source data which effectiveness versus difference between reliable and credible to select the effectiveness. Nishant?
So I'm reading the question again. Are there open source data which gives data on effectiveness versus difference between the drivable and readable? See, I think so. It's the basic fundamental. There's nothing which is required as open source data. If you are looking on the psychometric and you follow the constant readable blind based on the saturated efficiency of the manufacturer pad, because it will vary from manufacturer to manufacturer. What is the saturated efficiency can only be provided by the manufacturer. For reference, you can go to any standard manufacturers like Montas and all, and they have published those data. But it's better to always refer back to OEM to know the effectiveness. Once you know that saturated effectiveness, you can anytime extract it from the psychometric analysis.
Rather, the recommendation is not to apply the effectiveness value taken from one manufacturer on another manufacturer's equipment.
Absolutely. It will vary based on the phase velocity across the pad, based on the type of pad that you're using, the media, the thickness. There are a lot many parameters, it will vary. So it's better to take it from the OEM.
Sir, this is Kumar speaking.
Yeah, Kumar, please.
Sir, in the first session, we have discussed about personal cooling and desiccant dehumidification, and then we later discussed about evaporative cooling. So I would like to ask you that why can't we integrate the multi-stage evaporative cooling system to the liquid desiccant dehumidification and cooling system to provide personal cooling so that we can achieve individual level comfort conditions? So why are the Indian researchers not exploring in this particular direction?
Well, Kumar, good point. I'm happy that you brought this up. This is very important, and actually there is a paradigm shift that has started happening from space cooling to personalized cooling. There are still very few researchers who are working on personalized cooling system, but yes, liquid desiccant cooling is another important aspect which is less researched in India. People have done some bit of research. For example, IIT Delhi has done something, IIT Madras has done something. At MNIT, we are at a primitive stage. We are at a very initial stage for that. So the area you are mentioning is very important, very important. I foresee, maybe 10 years down the line or something, space cooling would be replaced by personal cooling because that is much more efficient and that is much more personalized. In the same open plan office, if 10 persons are sitting in 10 cubicles, each can control his temperature if personalized system is designed as per personalized cooling system rather than a common air conditioning system which is done conventionally. So yes, I think personalized cooling system is the way, is more efficient definitely, and liquid desiccant, yes, should find a place in that personalized cooling.
Sir, in that case, can we integrate a 4-stage evaporative cooling system with the desiccant, liquid desiccant system to completely, if not completely, the maximum part of the VCS system?
Yes, I think in IIT Bombay, there is some work going on in that direction.
Okay, sir. Thank you, sir.
Weber?
Yeah, that's it from the question part, I guess. If any have any question, then you can write. I guess we have answered most of the questions. So some
Just
people
in
are
case if there is anything, just in case if there is anything which has not been answered, I've in the chat box, I've mentioned the email ID. Please feel free to connect and we'll try to answer if there's anything which is left to be answered. Over to you, Weber.
Once again, appeal to all of you that please consider joining these two technical groups or whichever technical group you are most interested in ISHRAE. You have been made aware about the activities of these two technical groups. So since you have interest in these topics, we request you to join these groups and be active contributor or take advantage of that.
And adding to that, if somebody wants to download the white paper on thermal comfort, they can do it from ISHRAE website. It's free for all.
Shall we close?
Yeah, so so I would like to thank our panelists Sandeep and Nishant, and especially Professor Mathur and Vishal for their insights. And thank you for all attendees for their participations. And thank you, ISHRAE, for giving opportunity to attend such a wonderful webinar and topic. And in the end, I would like to say thanks to Saloni for hosting the webinar. So thank you. Have a good day.
Special thanks to Vaibhav, Mani, Yusuf for
Thank you, sir.
all of us.
For organizing it. Thank you very much.
Thank you.
Good day.